at 300 Kelvin. This room temperature energy is enough to populate the second state to some extent for the vibrational levels. Okay, so there will be some of the ground states and some in the excited. Most of them in the ground state, some in the first excited state. But if I am just talking of a harmonic oscillator model, then both these excitations would give me H cross omega only, one line, single line. Okay, but what about the rotational levels, which are 1000 times smaller in energy? Means that all of these levels would be populated to a large extent, right? And because of that, precisely, I could have excitations from level 1, L is equal to 1, 2, 3, 4, from all these levels. And that's why I can observe all these lines, right? You can imagine at room temperature, only the ground state will be populated for translational motion. Yes? So if you're given a problem, for example, that determines the bond length, I give you some other things as to what is. So obviously, from the bond length would come from this fellow I, which is mr square. The rest of them are constants, right? The other thing is, if I ask you to estimate the bond strength, if I tell you what the transition is and ask you to estimate the bond strength, then you know that it is H cross omega, which is equal to root of K by mu. And if I give you a molecule, of course you know its mass or its reduced mass. Right. Now, let me pick up these sheets. Those of you who have, good. Those who don't have, concentrate here. Oh, not this one, the one before this. Now, what the table tells you, so now we've just seen the energy levels, we have not seen the wave functions. All we had seen was the T part, the phi dependent part wave function, which was e to the power I n phi by root 2 pi. Okay, plus minus I n phi root 2 pi. But the theta dependence we had not seen. So this is the entire thing, theta and phi. So S of theta times T of phi. Now look at the first one, where N is equal to 0, N is equal to 0. And it's got absolutely no angular dependence, right? So whichever value of theta or phi I take, it should be exactly the same. And that's why it's shown to be spherically symmetric, right? It's spherically symmetric, it's a sphere. Okay? If I look at the second one, which says L is equal to 1, ML is equal to 0. Leave the constant, the rest of it is just cos theta. Now the picture that it depicts is that, look, theta is the angle that I am measuring about the z-axis. Yes? So that's my XYZ plane, and theta is the angle that I measure about the z-axis, right? So going back to that, then if I put theta equals 0, then cos theta is 1. So that is along the z-axis, the value of cos theta is 1. As I keep on changing the value of theta and I bring it to 90 degrees, okay, value of cos theta is 0, and then when I change from pi by 2 to pi, the value goes from 0 to minus 1. So all that this figure is showing you is the phase of the wave function, whether it's positive or negative. So in the upper sphere, it's absolutely positive. There's no phi dependence. So at whatever theta, wherever I see that, at whatever angle of phi, it doesn't matter, it's going to be the same for all the rest of the angles, all the rest of the values of phi. That's why it's very symmetric. We'll do that later. Actually, 2 of my videos are black because I just switch out the laptop so that's it. Here comes. So this one doesn't show you any shapes. All it is showing you is the sign, whether it's positive or negative. Unfortunately, this fellow sin theta e to the power plus minus I phi cannot be plotted because it has a real and imaginary part, right? But if I just take the real part, sin theta cos phi would be the real part. If I try to plot that, this would just turn over. The positive x-axis would have the positive hemisphere and the negative x-axis would have the negative hemisphere. But anyway, let's just ignore those for the moment. I come to L is equal to 2, NL is equal to 0. This below. 3 cos squared theta minus 1. Okay. So it must go to 0 at 2 points. Cos inverse of 1 by root 3. Huh? How much is it? I don't remember the value. Cos inverse of 1 by root 2 is 45. Yes or no? So 1 by root 3 should be slightly more than 45, maybe 50, 55, something close to that. Okay. Now, if I look at that, and then again I start plotting, saying what the value of theta is. So at theta is equal to 0, the value of the function would be 3 minus 1, that is 2 at the z axis. And then slowly it will come down to 0 at cos inverse of 1 by root 3. Right? From 0, then again it will start, it will have a small value and there is a minus 1 sign. So it will be negative, right? It will go on. At pi by 2, it will be minus 1. At cos inverse of 1 by root 3, minus cos inverse of 1 by cos inverse of minus 1 by root 3, sorry, it would again go to 0. And then again it would become positive. So this is all that it shows. Likewise, this you could practice for the next ones. But what this fellow is telling me is that, look, at for L is equal to 1, ML equals 0 at the equator or in the xy plane, I have something called a node. That's called a nodal plane.